Be sure to look for the answers to the following questions. How do GPS receivers detect their distance from satellites? What is the electromagnetic spectrum? What is static electricity? When you see this icon, the answer is near.
Dr. D's friend, Mr. Gano, works at NASA Langley Research Center. He develops new instruments for global positioning systems and has agreed to meet with us.
Hi, Tony.
If anyone can help us learn more about GPS, he can.
Pretty good. GPS, or Global Positioning System, is a constellation system of 29 Earth-orbiting satellites that were originally designed by the U.S. military in the 1970s as a navigation system.
29 sounds like a lot of satellites.
Why do you need so many?
It takes 24 satellites to provide global coverage, leaving 5 spares. The orbits are arranged so that at any given time, anywhere on Earth, there are at least 4 satellites visible.
Why do 4 satellites need to be visible?
Your GPS receiver needs 4 satellites in order to determine its own location.
How does our GPS locate itself?
By using a simple mathematical principle called trilateration.
I'm not sure simple and trilateration should be used in the same sentence.
What is trilateration?
It's kind of tricky to explain in 3-dimensional space, so let's start with a 2-dimensional example. Let's say you're totally lost somewhere in the US and your GPS is not working.
Like us, yesterday when we couldn't find our geocache.
As you are trying to find where you are, a friendly person tells you that you are 1,000 kilometers from Boise, Idaho. Do you know where you are?
No, I could be 1,000 kilometers in any direction from Boise.
Exactly. Now, let's say another friendly person comes by and tells you that you're 1,110 kilometers from Minneapolis, Minnesota. Do you know where you are?
Not yet, but I'm getting closer to my location.
That's right. Now you have 2 choices, but you still don't know where you are. Finally, another friendly person informs you that you are 990 kilometers from Tucson, Arizona. Now, do you know where you are?
It looks like I'm in Denver, Colorado. Which, of course, I will be soon.
The same concept works in 3-dimensional space, but instead of circles, you need to think in terms of spheres.
And the satellites are the friendly people telling you how far you are from a place.
That's right. If you know your distance from satellite A, you could be anywhere on a huge imaginary sphere at that radius. If you know your distance from satellite B, you can overlap the first sphere with the second sphere, and they intersect in a perfect circle.
So if you know the distance to a third satellite, you get a third sphere which intersects with the circle at 2 points.
Very good. And the Earth acts as the 4th sphere, so you can eliminate the point in space because you're on Earth.
So do you only need 3 satellites?
An approximate position can be found with 3 satellites, but to improve accuracy and get precise altitude information, 4 or more are better.
How do GPS receivers know how far they are from the satellite?
They analyze the high-frequency, low-powered radio signals from the GPS satellites and calculate the time the signal traveled.
Do satellites have stopwatches?
No, the satellites need to be more accurate than a stopwatch. The satellites use a very accurate atomic clock, which produces exact time-coded signals.
And what happens if a satellite malfunctions?
It's possible. Again, that's why we have 29 satellites when only 24 are needed, leaving a few spares.
It helps to have extra.
True. Here at NASA, we use GPS to determine the position of aircraft and satellites. And we also are developing a system to perform remote sensing of the environment. All of these tasks require precision information. Spare satellites make sure we get the data we need.
Cool. NASA's always doing amazing things.
Mr. Gano, what would happen if your GPS was only receiving a signal from 1 or 2 satellites? Would you get incorrect results?
No. Usually, your GPS device will let you know that it doesn't have enough satellites to calculate an accurate position.
Sounds like we need to do some more research.
Thanks, Mr. Gano.
You're welcome, and good luck with your geocaching.